Hi everyone, let's talk about the third problem of Biweekly 122. I absolutely loved solving this problem. Uh, um, Before I continue, if you like my explanations, please like and subscribe and introduce my channel to your friends. It's going to encourage me to create more videos. Okay, the problem says you're given a zero-indexed integer array, nums, containing positive integers. Your task is to minimize the length of nums by performing the following operation any number of times, like including 0. So, and the operation is that you can choose two numbers and you can remove them and instead add num_i %num_j at the end. So I'm going to tell you about my thought process, and then I'm going to talk about the example, because if I had thoroughly examined the examples, I would have come up with the answer way faster. Let me tell you about my thought process. So when I read this problem, I just looked at this second example, which is kind of trivial, and then I moved on and said, oh, okay, let's see what we can do. So the first thing that came to my mind is that the ordering of the numbers doesn't matter. So this is something that I always check. Does the ordering matter? And the answer is no, it doesn't matter. So I just kept that in mind. Then, because I had looked at this second example, I tried to create a DAG, like a directed acyclic graph. Like I said, okay, there is something related to numbers being multiples of each other. So 1, 2, okay, 2 and maybe 6, and 1 and 3, and 3 and 6, and 3 and I don't know, 9, and so on, and 2 and 10. So this is a DAG, and I worked on this DAG for a few minutes, but I couldn't come up with with an answer. I was looking for to find a path and do something with that path, but that was not good. And then I tried to think backward. So let me move this. Okay. Then I try to think backward. And backward, I mean, how does, by thinking backward, I mean, how does the array look like after the last operation? How does it look like? So, and my answer was, probably there are a few zeros, because we cannot do anything with zeros, and a 1, for example. And I was like, is it only a 1? Probably a 1. The 1 could, be there, is optional. And I was like, no, maybe, what if input is an 8? So the answer could be 8. So this is a non-zero, optional non-zero. And again, I couldn't do anything with this. I tried to think backward. I said, if this is 8 and 0, so this could have been 8 and 2 and 4, and this 0 have been 2 and 4. This 0 have been, for example, I don't know, 9 and 18, for example, and so on. But again, I couldn't work with this. And I said, oh, we are doing some division and, taking modulo. Maybe I can factorize the number into its prime factors. This was the next thing that came to my mind. And I said, interesting. What can I do? And I said, what if I have a, for example, and a is 2 to the 3 and times 5 to the 2 times, I don't know, 7 to the 1. And then I have b, and b is 2 to the 4 and times 5 to the 1 times 11 to 3. And then I was, okay, what happens if I do a modulo b? And here, the observation, this is the key observation, the solution clicked for me. And I was like, do I do a%b, or do I do a%b or b%a? And I was like, oh, if a is less than b, then a can eat b. Basically, this is eating. Like A. So A, B can become A if A is less than B. And this was great. And then from this point onward, it was just a few deduction to solve the rest of the problem. And I had a few cases, and I was like, if all of the numbers are unique, let me write it with this, because I type faster. Okay. If so first case is going to be if all of the numbers are unique. So what happens if all of the numbers are unique? And if you remember, we said the ordering doesn't matter. And for example, if we have 2, 7, 9, 10, 20, 30, 50, doesn't matter. So what happens here is that 30 can eat 50, 20 can eat 30, okay? 10 can eat 20, and 9 can eat 10, 7 can eat 9, and 2 can eat 7. So the answer is 1. And we cannot have an array that is less than 1. 1 is the minimum possible length, because we need 2, as per the operation, we need 2 numbers to convert it to a 1 number, to positive numbers. So I was like, oh, if all of the numbers are unique, nice. Okay, and my next one was, okay, what about what happens when we have duplicates? And here I tried to come up with a few examples. The first example I come up was something like, okay, I have 5, 5, 5, 9, 9, 9, 9, 9, 10, 10, 10, 10, 10. And in this case, I was like, oh, okay, so 5 can eat all of them. This single 5 can eat all of them. So basically, this was the case. Is the minimum unique? If the minimum is unique, the answer is, if yes, the answer is 1. Like this example, like 5, 10, 10, 10, 10, 20, whatever, 33, whatever. Okay, and here this 5 can eat all of them. So at the end, it remained just solve the case. This is the last case. Solve the case when the minimum has duplicates. And this could be the example, like 5, 5, 5. And I have a few other numbers, 10, 20, 30, 45. And here I tried for a few seconds to work and see if I can generate a number that is less than 5. Okay, so this actually becomes 2 cases. So 5, 5, 5, 5, 12, 20, 30, 25. So in this example, I can do a 5 and I can take 12 and 5. So I can take this 12 and 5. So 12% 5 is 2. So that means now my minimum is unique. So I can have a minimum that is unique. So I found a number that's 12, like AI percent mean is not 0. That means that this is definitely less than mean, right? When you take the modulo of a big number by a smaller number, the answer is going to be smaller than minimum. So the answer is going to be less than 5. And now this is unique. So this 2 can eat all of them. So so it becomes like this. If there is a number such that AI percent minimum is not equal to 0, the answer is 1, because I can create a number that is less than minimum and then eat all of the numbers. Okay. Otherwise, this is the case. I'm gonna paste it here. Okay. Otherwise, all of the numbers are multiples of 5. All of the numbers are multiples of the minimum. And in this case, you can try, but no matter which two numbers you take, the answer is going to always be multiple of 5. Like if you take 40, 45, and 30, you're going to produce 15. If you take 30 and 20, you're going to produce 10. If you take 20 and 30, you're going to produce 20. And no matter what you do, you cannot run away from like having a multiple of 5. So here the answer is like take one of the 5s, eat the rest of the array. So this becomes 5, 5, 5, 5. And now let the 5s fight like with each other and eat each other. And so here, the example in this case is that the first two 5 becomes 0, and the second two 5s become 0. So the answer is 2. And in general, if you have 1 5, you can't do anything. It's just 1 5. If you have 2 5s, you can have 0, 1 0. If you have 3 5s, you can have a 5 and a 0. And if you have 4 5s, you can have 2 zeros. So the answer is ceiling of the number of 5s by 2. So if it's 1, it becomes 1. If it's 2, it becomes 1. If it's 3, it becomes 2. If it's 4, it's become 2. And now we solved it. We solved all of the possible cases for this problem. Let's go and see the code. The code is going to be very precise. So what here we need to do is to, if all the numbers are unique, this doesn't matter, we said, so only the minimum matters. So we should find the minimum and count the minimum. So here it's going to be int minimum mean value. It's going to be mean element of nums that begin end. So it's going to be a star of this. And int mean frequency is going to be count of nums that begin and nums that end, and mean value. So if mean freq is 1, return 1. Okay, if mean freq is 1, return 1. That's it. That's it. Otherwise, check if here, if there is a number such that AI minimum is not equal to 0. So for auto x nums, if x% mean value is not 0 equals false, I'm going to call that found number equals true. So here, if found number is true, again return false. Sorry, return 1. And here at the end, we just return the ceiling of count 5. So return mean freq plus 1 by 2. This is how we do ceiling. And that's it. That is the code. I think, let's see. Okay, 1, 2, 1, and submit. Accept it. So that is the code. Can we simplify this a little more? Think about it. Can you like write a more simplified version? It doesn't matter in terms of like writing this solution in the contest, but in production it matters, like to have a shorter code. See you in the next problem.